Okay, section 3.5, problem number 21. In 21, we are given y is equal to sine of x plus 3 at x equals pi, and we are...
Oh, sir, is this bedtime?
Yes, this is a terrible time.
Is there any time I can come back?
When I'm not teaching.
Is there any specific time?
I don't know how far we're going to get today.
That's fine.
I can't speak. All right. I'm glad that's on the recording. All right. And we want to find the tangent and the normal curve to this curve at this point. Okay. What do we need? Let's be really organized. Slope is one thing we need. And a point. Okay. So we have part of one point. We have the x-coordinate of the point.
Find the y.
Let's find the y. The value of y when x equals pi is equal to sine of pi plus 3. Sine of pi is 0 plus 3. Okay, so now we have the point, pi comma 3. What else we need? You said we need the slope. I use m to signify the slope. And how are we going to find the slope? It's the value of the derivative when x equals pi. But you know what? I want to be more organized than this. This is going to be finding the value of slope at that point. I want to find the general formula for slope first, and then do this second. So if you don't mind, I'm going to take a step backward. I'm going to say, well, what is the derivative first? Then I'm going to find the value of the slope second. So what is the derivative with respect to x of sine x? Cosine x. What about the derivative of 3? 0. The derivative of any constant is, now that I have that, now let's say the slope is equal to dy dx when x is equal to pi, and that's equal to cosine of pi, which is equal to -1. And now we have the elements that will help us find the tangent line. So let's very clearly declare, what are we finding? The tangent, and it's equal to y equals the slope, -1 times the quantity, plus 3. Now the book won't give you the answer in this form. It distributes the -1 through, and so they says -x plus pi plus 3. What about the normal? And very clearly I'll state I'm finding the normal now. How much does it change from the tangent? We use the opposite reciprocal of that slope. So we get, whoops, write out really clearly. Y is equal to 1 times x minus pi plus 3. Of course, they don't like that form, so they would say x minus pi plus 3. If you wrote that in an open-ended problem in that form and left it that way, I'd be perfectly fine. The problem is, as you've seen from our quizzes and tests, there's a lot of multiple choice, and we need to make sure that we go from that perfectly legitimate form to one that actually matches one of the answers. Okay, can we confirm this graphically?
Yes.
Let's do that.
Is the second way the way you want us to write it on the page?
The second way is the way I want you to get in the practice of writing it, so that the first time you're doing this on a test isn't. So I want you to do it all the way to that point. Yeah, I've modeled exactly the way I want you to do it. All right. So let's go over to the. Let's go over to here and let's graph our functions out. Sine of x plus 3 is one function. Our tangent line is going to be -x plus pi plus 3, and then our last one is x minus pi plus 3. Which zoom should I use? Zoom trig. I think so too. Zoom 7. And then let's go to big screen. Okay. Does it look like we got a line actually touching the sine curve?
Yeah.
Does it look like the other line meets it at a right angle? Probably not until I square it up. 5. Let's just see if when we square it up, it looks quite right angle-ish.
Not really.
It's a little bit better?
So
Okay.
it's like 110 or something to 70.
Okay. So there's problem number 21. What's next? 23? Okay, in 23, it's another tangent and normal problem. Again, let me model exactly what we want. Got x equals 3. All right. Now, if we try to model exactly what we did in the previous one, what was the first thing that we did? Put the x into y because we need to find the complete point. What notation did I use? Think to yourself, what notation did we use? The value of y, line, when x equals 3 is equal to. Now, if I want to stay in exact mode, meaning I want to write an answer that's absolutely flawless, absolutely accurate, I would write 9 sine 3. That is a number. That's exactly the number. But there may be cases where they actually want you to find the decimal representation for that. So let me break my calculator back out. 9 sine 3. So, and how many digits are you to write? No. 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 All. You never round until the end. All right. So let's continue on. What was the next step? What was the next thing we did? Find the derivative first, and then we can find the slope. So let's go ahead. Let's find that derivative. The derivative of y with respect to x.
X squared times cosine x.
That's not what I would say to myself.
No.
No.
X squared.
First. What am I talking about? I'm talking about the mantra for the product rule. First. First times the derivative of the second plus second times derivative of the first equals x squared times cosine x plus 2x times sine x. General form for the derivative. Now what? Plug in 3. Notation, please. Nope. What are we trying to find? We're trying to find the slope. No, stop. M, because we're trying to find the slope. How do we find the slope? It's a derivative at the point. Slope equals the derivative at a location. Slope equals derivative at x equals 3 And that's equal to 3 squared cosine 3 plus 2 times 3 times sine of 3, which is 9 cosine 3 plus 6 sine 3. And that's an exact answer. If we need to, then we can find an estimate of that value. Let me confirm that.
Got an honest to know there.
So negative 806 3212421. Okay, great. Oh, get back. There we go. That was close. So what's left? Put it in point slope form. Or how about we're going to declare what is it we just found? That we have the ability to say now. The tangent line is y is equal to, and if I want to write out all that at this point for my final answer, if I wanted to, I could indeed round to 4 decimal places.
That's not the slope.
That's the y value.
That's the y value. Good catch. It happens. There we go. Negative 806 3 times x minus 3 plus 1.270. If you want an estimate of the answer, that's a reasonable estimate. What about normal?
1 over negative.
Declare what? Wait. First of all, declare what we're finding. Oh, we're finding the normal now. Y is equal to 1 over 8063 times x minus 3 plus. Okay. Now, to get the answer in the book, they probably find the value of that. They probably distribute both of them.
This is most likely to be a test question, right?
Well, I don't know. How many times have you been asked to do normal or tangent curves in this class? In every single assignment. So what do you think the message is about the importance of the problems of this type? I can guarantee it. All right. 25. 25. Assuming that we know the derivative of sine and the derivative of cosine, can we prove that the derivative with respect to x of tangent is equal to secant squared? I thought I did that in class.
Yeah, we don't need to do this part, we need the second part.
The second part. Can we show that the derivative with respect to x of secant
Yes, we can.
is equal to secant tangent? Okay, let's go ahead and start that out. Let's start here. Here's where we're going to start. And here's where we're going to end. So I'm going to start with the derivative of secant, which I acknowledge is the derivative of 1 over cosine. Okay, don't we have to do this one? I did this one in class. It's part of the lecture. Okay, so 1 over cosine. Phil said what? Quotient rule. So, quotient rule mantra? Bottom. All right, hold on. I do bottom, you say bottom, I write the bottom. Then you say derivative of the top, so I write derivative of the top. Okay, let's continue on. What is the derivative with respect to x of 1?
0.
So this whole thing goes away.
Positive sign of x.
Well, it's -1 times
Negative 1 times negative sign of x, because negative sign of x is the derivative of cosine, all over cosine squared. Those two signs cancel each other out, and so we end up with sine over cosine squared, which is not the answer. That's not where we're supposed to end. But what are you going to say, Lucy?
It's tangent is sine of cosine, and the cosine on the bottom, which is
I can rewrite this as sine over cosine times 1 over cosine. Split the cosine squared into 2, and the first part is tangent, and the second part is secant. So we started at the right place, didn't break any rules, ended at the right place. Who's huzzah? That's the word I'm looking for. Okay, number 31 is our last one in this batch. 31.
Wait, you know you put secant, you know that one?
You put
You put secant x. Is it supposed to be that, or is it supposed to be secant squared?
no, it's CNX.
This is the one that we didn't do because we did it in the collection notes. Here's the one that we did do. Start with secant and end with secant tangent.
Oh, alright, I was just making, I like that.
So that's
confusing.
B, not
That's, so this is the, what we did was the B part of the problem.
Alright, okay.
Right? All right, I'm glad we got that taken care of. 31. I am okay, in 31 we've got a diagram. And the diagram looks something like this. And right at the top of the curve is a point Q. And over here there's a point P. And they tell us that P is pi over 2 comma 2. They have a tangent line through here. And they have a tangent line through there. And they ask us to find the tangent through point P. And then they ask us to find the horizontal tangent at Q. All right? And we're told that this curve is y is equal to 4 plus cotangent x minus 2 cosecant x. All right, let's find the line tangent to P first. C. To do a line tangent, I need a point and a slope. Point P, I have the point. It's pi over 2 comma 2. Check mark. Got that part done. So what do I need is the slope part. To find the slope, find the derivative with respect to x of y. No, we got to find the derivative first, then we do the when after. So the derivative of 4 is
0.
the derivative of cotangent. It starts with a co. Negative cosecant squared minus 2 times the derivative of cosecant. Negative cosecant x cotangent x. Cleaning that up, I get negative cosecant squared minus, oh sorry, there's a negative sign, plus 2 cosecant x cotangent x. Did I do that right?
Yeah.
All right, and now I can ask the when question. What is the derivative? Oops. Let's do the same notation. Do it the same way every single time. Slope is equal to dy dx when x is equal to pi over 2. Who has a question? Yeah.
How come you don't do the product rule for -2 cosecant?
Because 2 is a constant multiplier. I could do the product rule. It won't matter because when I take the derivative of the first, the derivative of 2 is 0. So I get 0 times the second, which means it will go away anyway. All right. So the value of the slope, the slope is the value of the derivative when x is equal to pi over 2. So I get negative cosecant squared of pi over 2 plus 2 cosecant of pi over 2 times cotangent of pi over 2. Pi over 2. See, pi over 2, sine is 1 and cosine is 0. Cosecant is 1 over sine. Pi over 2, sine of pi over 2 is 1. So this is going to be 1 squared with a negative in front of it. So this part here is going to be -1 plus 2 times cosecant at pi over 2 again is 1. And then cotangent. Cotangent is cosine over sine. At pi over 2, cosine is 0 and sine is 1. It's 0 over 1. It's 0. So that goes over 0. All I got is -1.
And that's our slope.
And that's our slope. So, tangent at P, y is equal to -1 times x minus pi over 2 plus 2. Or -x plus pi over 2 plus 2. Now, take a look at that tangent line. Does that look negative?
Yeah.
Okay,
Good.
that's good. Quick check. All right. Now, what about at P? Sorry, at Q. We already did P. We need a point. We don't know the point. No, we do.
Zero.
We set the, what is 0? Yeah. What is this it stuff? The slope at Q is 0 because it's a horizontal tangent.
A number.
So it's going to be in the form y is equal to some number because it's a horizontal tangent. What we need to do is find out what the y value is. Well, how are we going to do that? What we want to know is when does dy dx equal 0? For what value of x am I going to get 0 for the slope? So when does negative cosecant squared,
But that's for a different line. Wait.
nope, this is all the same curve. This
Oh, yeah,
derivative
yeah.
is for everything on that curve.
Yep, I got it.
Negative cosecant squared plus 2 cosecant cotangent. When does that equal to 0? It looks awful,
This is awesome.
but we can do it. First step, let's break these onto either side of the equal sign. How about I take this negative cosecant squared, put it on the other side. So I get 2 cosecant x cotangent x is equal to cosecant squared x.
So take out a cosecant.
I can divide both sides by cosecant? Sure.
Yeah.
That one goes away, and that turns into a 1. Now watch what happens. 2, what is cotangent? It's cosine over sine. I don't know how I turned into a... Also, my variable turned into a t. Cosine x over sine x. And what's cosecant?
1 over sine.
1 over sine. Hey, how about I multiply both sides by sine?
Cosine x equals
Oh, when does 2 cosine x equal 1? Oh, that's when cosine x is equal to 1/2. Isn't that one of our classic angles?
Yeah, but pi
1, 2, root 3. Cosine would be of that angle, the adjacent over the hypotenuse. That is x is equal to pi over 3. Okay, so is the difficulty getting to the point where I said cosine of x is equal to 1/2?
Yeah, I think of it in units. I don't know, a triangle.
Okay. Okay, a side note here. There are only 2 triangles that were ever expected to find angles for. Except for the ones at the 90 degrees. All right? And that is the triangle 1, 2, root 3, where the angles are pi over 3 and pi over 6, or 1, 1, root 2, in which both of the acute angles are pi over 4. And you should be able to, given pi over 4, pi over 3, or pi over 6 as an angle, find any of the 6 trigs. And you should be able to do the inverse for the 6 trigs, where the answers are pi over 4, pi over 3, or pi over 6. Yeah.
Can't you just do the same thing with the unit circle?
That is the unit from the unit.
Those are from the unit circle. Well, actually, no, they're not, because I'm making the hypotenuse something other than 1. If you know it a better way and you get consistently the right answers, I'm fine with that. All right. So when I get the problem, cosine of x is equal to 1/2. Okay, I'm thinking about cosine. What's the one triangle that I have where the hypotenuse is 2? It's this one. Cosine is adjacent over hypotenuse. So here's adjacent, here's hypotenuse. I must be talking about pi over 3. That's the way I do it in my head. All right. Back to this problem. If x is pi over 3, what's my final answer? Oh, I'm going to need to find out what is the value of y when x is pi over 3. I plug it back into my original function, 4 plus the cotangent of pi over 3 minus 2 times the cosecant of pi over 3. Good thing I have my reference triangle here. This is equal to 4 cotangent of pi over 3. Pi over 3 is here. Cotangent is adjacent over opposite. Adjacent over opposite. That is 1 over root 3 minus 2 times cosecant. Cosecant is hypotenuse over opposite, which is 2 over root 3. Can I clean that up at all? I've got 1 over root 3, and I'm subtracting off 2 of them. I have 4, sorry, I'm subtracting off 4 of them. 2 times 2. So negative 3 over root 3, or 4 minus 3 root 3 over 3. Those 3's cancel. How about 4 minus root 3? 4 minus root 3. That was a big problem. But it's done. All right. How much time do we have left? 12 minutes. Let's see how much more damage we can do in the other section then. Let me save this.